Crossplane was designed to act as a universal control plane through which we can manage all types of resources across any number of providers. That means that we can use it to manage infrastructure, services, and applications. Everything. Now, speaking of applications, I already demonstrated in one of the previous videos, and the link is in the description, how to create production-ready clusters. And by production-ready, I mean not only infrastructure like subnets and VPCs and node groups and so on and so forth, but also applications that should be running in those clusters like Prometheus for monitoring, Argo CD for GitOps, and so on and so forth. But we can go a step further and use crossplane compositions combined with Kubernetes provider to define what an application is. And through such definitions, simplify management of our applications and potentially shift left, enable developers to manage applications themselves. And there is a good reason to define what an application is, simply because Kubernetes itself, what comes out of the box, core Kubernetes, does not have a concept of an application. It has a concept of a bunch of resources like ingresses and services and virtual services and so on and so forth, but those resources are low level and hard to grasp by people who are not invested heavily in Kubernetes. So today I'm going to try to change that. I'm going to combine Kubernetes provider with crossplane compositions in an attempt to define an application that is easy to grasp, easy to manage, and through that I'm going to try to hide complexities that are not necessarily relevant for developers but are very important for operators or SREs. So I'm going to split it into two different personas. We're going to have an SRE that is defining what an application is, and that SRE is going to enable a developer to manage applications in an easy way with only the information that is relevant for such a persona. So let's get going. Let me jump straight into a demo and see whether we can accomplish those goals. My name is Victor. I work for Upbound. We're a company behind your favorite tool, Crossplane. Let's say that I am a developer who is working on a front-end application and would like not only to write code and write tests and execute tests and build stuff and so on and so forth, but also to manage that application, to deploy it to staging, pre-production, integration, production, whichever environments there are. As such a developer, I would like to define what an application is and also to manage the life cycle of that application. For the sake of brevity, I will skip automation, I will skip explaining how we should be using GitOps tools like Argo CD or Flux, how we should have CI/CD pipelines and so on and so forth. I'm going to do things manually today, but you should automate everything I'm showing you through CI/CD pipelines, GitOps, and so on and so forth. So going back to me being a developer and working on a front-end application, and let's say that I defined such an application, and that application could look like this. Examples app frontend.yaml. So here we are. This is a completely new custom resource in Kubernetes that defines an application claim. Claims in Crossplane are extremely useful because they enable us to create namespace scoped resources so that I as a developer or anybody else have certain permissions to do certain things in a certain namespace instead of having cluster-wide permissions. What matters here is that this resource is based on a custom resource definition made specifically for my organization, created by an SRE or a person who has deep understanding of Kubernetes, understands very well what is needed, what is not needed, and so on and so forth. But I, as a developer, do not need to worry much about that. What I really need to worry is to select the type of the composition I want to use and the parameters that should fine-tune the behavior of my application. So the composition is selected through labels. Here I'm saying, hey, I want a composition based on this app claim that has the label type set to frontend. There are other types of applications I could be defining, but in this case I'm working with something that is identified through the label type set to frontend. And then I'm defining some parameters. I want that application to run in the namespace A team. I want the image to be this one. This is the image of my application, and the host should be this one, whatever the host is. Now, what those parameters are will differ from one organization to another, or even from one team to another. Those parameters are defined in the composite resource definition, which was written by an operator or SRE, and I will show you that one later. For now, I'm still acting as a developer. I do not care about those things. What I do care is to say what my application is. In this case, it is frontend, and to specify specific parameters that are important to me. And in this case, I'm going with potentially the easiest possible set of parameters, which are image. This is the image of my application, and the host. This is the address through which my application should be exposed. In a real-world situation, I would push this definition to a Git repository, and then Argo CD or Flux would make sure that what is defined in a Git repository, what is the desired state, is synchronized with my Kubernetes cluster, the one where Crossplane is running, and from there on, Crossplane would take care of doing whatever needs to be done. However, today I'm not focusing on GitOps, I'm focusing on demonstrating how we can create applications definitions in Crossplane, so I'm going to skip that and apply this manifest directly. And I can do that with the command kubectl --namespace a-team, and I want to apply something defined in a file examples app frontend.yaml. And there we are, I created my frontend application. Now the application is much more complex than this, but that is not important for me as a developer. And I can confirm that the claim, the application itself, was created by executing kubectl --namespace a-team, and I want to get all app claims. That's the name of the resource definition that was created for me by Crossplane and defined by an SRE. So there we are. There is my application called DevOps Toolkit. It is accessible through this host, and it is ready. It is ready to use. It should be up and running. So let's confirm that by executing kubectl --namespace a-team. I want to retrieve everything, including ingresses. And this is the output. I can see that my application was created. It has a service and it has a deployment. The deployment created a replica set created pods. There is horizontal pod autoscaler, and there is ingress. Typically, I would need to define all those resources, but in this case, I'm not doing that because I'm using Crossplane composite definition, which in turn will use a composition that will create all those resources, or to be more precise, it already created all those resources. And if I take this address and open it in a browser, my application should be up and running. So let's take a look whether that's really true. Here we are. There's my application. It's running. Yay, look at it. My application is up and running. It's a front-end application, and I did not need to worry beyond the things that really matter to me as a developer. And what matters in this hypothetical context is to say it is front-end, it lives in this namespace, this is the address through which it should be accessible, and this is the image. Now let's say that I want to manage a backend application as well, and that backend application might need to behave differently than frontend. For example, it might not need ingress because it is not accessible from outside of the cluster, and it might need some other things. So let's see how I would do that. It's stored in examples, app backend.yaml. Here we are. It's another app claim, meaning that it's the same interface as before. Same parameter source, same parameters that we might choose to use or not to use. What really matters here is that I'm using a different labels to select which composition I want to use. I want to have a backend application, and parameters are slightly different. I'm using an image here just as in the frontend application, but I do not have ingress because backends should not be exposed to the outside world, at least in the context of what I'm doing right now. And I'm saying, hey, the port should be 8080. The default assumption is that the application listens on port 80. That's why I did not specify the port for the frontend, because the frontend happens to be listening on port 80. But the backend, in this case, the application itself, is configured to listen on port 8080. So I need to overwrite the default port by saying, hey, in this specific case, the port should be 8080. So I'm going to apply the definition by saying, hey, kubectl namespace is a-team, just as before. I want to apply. File name is examples app backend. Was it backend? Yes, backend YAML. And again, I'm creating a single resource, and Crossplane is going to make sure to expand that resource in whatever is required for, in this case, backend applications. And now I can double check that everything looks good by executing kubectl --namespace a-team, and I want to retrieve everything, including ingresses. And we can see now that there is a second service, silly demo. There is a second deployment as well. Deployment created a replica set created one pod. Unlike frontend that scale to 2, this one has only one because there is no horizontal pod autoscaler. I'm imagining that for backend applications, horizontal pod autoscaler is not needed, which is rarely or almost never the case, but I just wanted to make sure that you see that we can have as many varieties as we want to have. And finally, there is no ingress because this backend does not need ingress. Similarly, I could update my applications. So I will edit the definition of my application, which is in examples app frontend, and I will change, let's say, the tag from 400 to 410, and I will apply those changes by executing kubectl -- namespace a-team. I want to apply something defined in a file name examples app frontend.yaml. Was it that one? Yes. Now it's configured, and if I list all the resources, I should see my changes, right? Namespace a-team get all, and I can see that there is a new deployment. Deployment was updated. I cannot see that directly, but what I can see is that there is a new replica set over here because the deployment was updated and everything should be working fine. I have a new release running, and we can see that by the age of the pods, which is 15 seconds and 14 seconds. So the new release was updated, and I did not need to bother with deployments or ingresses or services. Whichever resources are required to run applications, I can focus on application itself, which was defined by somebody else, or the components of the application were defined by somebody else. And speaking of that somebody else, let me change my role, and now I'm not a developer anymore, now I'm SRE, and I'm going to show you how I created all those definitions. To begin with, I have Crossplane configuration, which simplifies distribution of what I'm going to show you, and the package is here in Crossplane config app. So I packaged my definitions, all the definitions of what an application could be in a configuration. I pushed it to, in this case, Docker Hub, to my container registry, and it is available as Crossplane app version 0.1.1. Now, the actual manifests are slightly more complex, and they are in packages, app definition.yaml. This is the interface that I defined. This is the interface that creates the composite resource definition, which has the, where is it? The OpenAPI schema that defines the interface that developers or anybody else who manages applications can use. And here is the list of all the properties that I used before, like namespace, image, port, host. Some of them have default values, like port is by default 80, so you do not need to specify the port if your application listens on 80, and so on and so forth. And then I created compositions that implement this interface, and one of those compositions is here in packages app frontend, right? So we have a composition that is implementation of the Crossplane resource definition that I showed you earlier. There's also the label that allows one to choose this composition over other compositions, and in this case that label is frontend, that explains that it is about frontend applications. In the resources section, we have Kubernetes provider configuration or provider config that is set to injected identity, which means that it should be configured to use Kubernetes where it is running. So it's not a remote Kubernetes. In this case, I'm assuming that one wants to use this composition within the same cluster. And the rest is pretty straightforward. We're defining a deployment, and then we are defining, what else do we have here? A service, and a few other resources like, what do we have here? Ingress, and there must be at least one more. Here we are, horizontal pod autoscaler. Some of the values of those manifests are overwritten in the patches sections, like in this case the name and the namespace and some labels and scale target reference as well. And the same thing goes for the other resources. If you're already using Crossplane compositions, you should have no trouble setting this up or something very similar to this. And the goal is to wrap all the different Kubernetes resources we need for running specific type of Kubernetes applications and expose them as a new interface, as a new custom resource definition, or to be more precise in this case, Crossplane resource definition. And the same logic is used for the second composition, which implements the same composite resource definition, and that one is, where is it? Packages, app and then backend. Here we are. The logic is exactly the same as for the front end, except that we have variation of the same resources, some new resources, some resources are missing. Like in this case, backend doesn't need ingress, so it is not present, and so on and so forth. And that's all there is to it. If you're already familiar with Crossplane compositions, you should have no trouble creating new composite resource definitions, except that in this case, they're defining different types of Kubernetes applications. The logic is almost the same as if you would create a composition to create a Kubernetes cluster or a database as a service and so on and so forth, except that we are here using a different provider, Kubernetes provider, and all the rest of the rules are the same. And if you're not familiar with Crossplane compositions, then there is a link in the video. Check it out. Thank you so much for watching. See you in the next one.